Okay, so for this first section of videos, we're going to talk a little bit about textile density. So we're going to kind of start with this course. We kind of try and go through the foundations of everything. So the first thing to talk about is textile density. And what is textile density? Basically, textile density, in reference to an object or to an asset in your world, is how much resolution, how much texture resolution is represented on a mesh in game. Okay, um, and there's a ton of information on this, and there's a ton of different um, mindsets on this. My uh, general opinion about this is that this is a very great guide to follow, but every production I've been in, that you know we that you tend to when you try and ship stuff, things start to get kind of a little bit out of whack. So it's a great thing to try and maintain, but sometimes it doesn't always stay that way. Basically, textile density is a way to calibrate and measure your object's resolution in comparison to other objects in the world. Okay, that's a very fancy way of saying is if you have a rock A, next to tree A, the texture map, the UV map that's on there, will be displaying the same amount of resolution from that rock to that tree. Okay, so if you have a big wall, same thing. That big wall is going to have the exact same resolution as a piece of machinery sitting on the floor next to it, or at least that's the hope. Okay, now how do we determine that? Um, we determine that a number of different ways. Primarily, the most common way is to base it off of the character scale. So depending on your game, depending on your pipeline, your character scale is going to be primarily based off of a 2048 texture resolution, and multiple 2048s at that. Character resolution tends to be obviously substantially higher than the environment resolution, but it's a good unit of measure. Um, One of the things that you'll actually want to make sure you're doing when you're setting up all your units and that kind of stuff is to make sure that whatever engine you're using, that your unit setup is corresponding to that. So for this first set of, like for this first little lecture, um, we're going to talk about the unit scale in relation to UDK, which is not Unreal Engine 4, but UDK. And then we're going to migrate this process over to Unreal Development Kit 4. The idea behind this being is that if you follow standard texture resolution scale and grid snapping, your objects can scale likewise with your engine. Okay, so and that'll make sense as we go more into the videos. Um, so the first thing that I'm trying to do here is I'm setting up my grid snaps here, making sure everything is set up and aligned. One of the things that you're going to find when, as you're doing this stuff, you tend to want to work in whole numbers. It's something that's absolutely very important. It makes it much easier to use inside the engine where you can. Another thing too that you want to be very mindful of, and again, we're going to talk about this when we go into this, is that your models, get used to having them onto the grid. Okay, we're going to be using the grid a lot, especially for game art. Um, Basically, grid's your friend. Stop fighting with it. Make sure you use it. Um, Basically, what you want to try and think about is if it's a wall piece or some type of pillar, or something that's got to snap around. You want the outmost extents of the objects or anything that's it's going to snap against to snap onto a grid. Okay, Unreal 4, I believe, uses centimeters. For the sake of simplicity, keep everything inside a max at one default value of one, and then you can switch it over to centimeters if you'd like. Which actually I probably recommend because it's going to help you if you're migrating your stuff across other platforms, and it also helps because every other country in the world uses centimeters, other than the U.S. And centimeters is just a nice even number to use. Okay, but you can see here, using those full integer numbers, no float, no decimal point numbers, everything will snap onto the grid, right? Everything just kind of works. So that's a really important thing to remember when we're setting up our blockout assets. And again, we do this, so as you can see here, everything will just snap. Okay, and when we take the objects into Unreal, this is going to be very important. Okay, so this is kind of the method that we're going to follow the most in this first part of these very large series of tutorials is the idea of prop snapping and modular asset design. And again, we'll take this into varying degrees of complexity. I kind of like to start all my tutorials off with fairly basic things. Um, One of the advantages to actually doing um, modular design is for asset culling. Basically, asset culling is if this is your camera, your game character or camera. Anything that camera frustum doesn't see, it's going to cut out. Okay. And as you can see here, we're only saving a few assets, but this is a very quick way for your objects to be able to drop in and out of memory or in and out of the frame, so you don't have to actually translate the vertices in camera if you're not seeing them. So one of the advantages to modular design is that it's very efficient for rendering. You can drop stuff, you can instance stuff, which is rendering saves you on calls for new objects and whatnot. So there's a lot of really cool things that come from modular prop design, and it's very popular, especially with the Unreal Editor and the Unreal Engine and how popular that whole workflow's come. Not every engine utilizes that. If you're using an older engine, they may be more BSP based, which is binary space partition. And a lot of that stuff they use props, but there's probably not so much prop modeling. Um, and again, this is we're going to talk a little bit about as many workflows as I can, but again, every engine's different and every company works a little differently within their engine, so it's important to realize that as well.